Assalamualaikum everyone. My name is Muhammad Amin. Today I am here to solve the simple paper solution of Skoltech scholarship test. Today's question is from physics portion. The question is two identical solid balls with masses m is equal to the 0.15 kg are connected by a spring with spring constant k is equal to the 0.875 Newton per meter. Then a third ball of the same mass m is equal to the 0.15 kg moves with the velocity of v0 is equal to the 1.2 meter per second and hits one of the two balls. The system of two balls hits the system of two balls. The collision is absolutely elastic. Then what is the maximum amplitude x maximum of the spring oscillations after collision? The options are x maximum is equal to the 0.25 meter, x maximum is equal to the 0.5 meter, x maximum is equal to the 0.35 meter, x maximum is equal to the 0.1 meter, and x maximum is equal to the 0.15 meter. Let's try to solve the given question. Okay. So the given data of the question is m1 is equal to the m2 is equal to the m3 is equal to the m is equal to the 0.15 kg and the spring constant of the spring k is equal to the 0.875 Newton per meter and the velocity of the mass 1 is equal to the 0.12 meter per second. So we have to find the amplitude x maximum. Okay, as mentioned in the question is the collision is completely elastic. For elastic collision, the momentum before the collision is equal to the momentum after the collision and the kinetic energy before collision is equal to the kinetic energy after collision. So the first condition for perfectly elastic collision is initial momentum is equal to the final momentum, means momentum before the collision is equal to the momentum after the collision. Here momentum before the collision is only one mass. Okay, the velocity of the system of the masses connected with the spring is zero, so only the momentum of the velocity so only the momentum of the first body plus zero times the so only the momentum of the moving body will be considered. So only the momentum of the moving body will be considered. So before collision, only the first body is in motion. So its momentum is m naught into v naught is equal to the after the collision. You will see that the first body comes to rest and total energy is transferred to the second body. Means head-on collision will occur, and the momentum after the collision will be equal to the mass of the body 1 into velocity of body 1 plus mass of the body 2 into velocity of body 2. Now we know that the m is common out from this from the right side, so it will cancel out. So v0 is equal to the v1 plus v2. In term of v2, we can written as v2 is equal to the v0 minus v1. Okay, now from the second condition of the elastic collision, we know that kinetic energy of initial is equal to the kinetic energy of final, means the kinetic energy before collision will be equal to the kinetic energy after collision. So only the moving object before collision is body 1. So the body 1 kinetic energy is equal to the 1 by 2 m v naught square is equal to the after the collision two bodies will be motion. The system of bodies that is connected to the spring are in motion. Okay, now the kinetic energy after the collision will be 1 by 2 m v1 square plus 1 by 2 m v2 square. From here v2 is equal to the v0 minus v1. We can replace, okay, here 1 by 2 will be 1 by 2 m by 2 will be common out from the right hand side, and the m by 2 will cancel out, and this equation will gives us this one by cancel outing the mass factor and the 1 by 2 factor. Okay, now by placing here the value of v2, okay, v2 by placing here the value of v2, it gives us v0 square is equal to the v1 square plus v0 minus v1 whole square. Okay, now here the formula of 1 minus b is used. 1 minus b whole square is used. According to the 1 minus b whole square formula, a square minus 2ab plus b square, where a is a naught v naught and b is v1. Okay, naught square and v naught square will cancel out. v1 square plus v1 square gives us 2v1 minus 2 into v naught into v1. Now the 2 here is common, and by dividing 0 by 2 it gives us 0. Then the final equation will become v1 square minus v naught into v is equal to the 0. We can common out the v1. Okay. then it becomes V1 into V1 minus V0 is equal to the 0. So here either V1 will be 0 or V1 minus V0 will be 0. Two factors are multiplied with each other and its result is 0. So either both of them will be 0 or any of them will be 0. Now by comparing with the first one, V1 is equal to the 0, and by comparing with this factor it gives us V1 is equal to the V0. Now in the question we know that it is a complete elastic collision. For complete elastic collision, head-on collision will be occur if two body having same mass, okay, and the second body is in rest, and this condition here satisfied that the second body 2 is in rest and the first body is in motion, and the body 1 and body 2 have same masses. So here the head-on collision will be occur and the velocity of the first body will become 0 and total energy will be transferred to the second body. So this is satisfied according to the elastic collision. Okay, now V1 is equal to the V0. This has no any physical interpretation. So here we take the condition of only the elastic collision one, that is the V1 is equal to the 0. Okay, so here V2 is equal to the V0 minus V1. By placing the value of V1 here, it gives us V2 is equal to the 1.2 meter per second. Okay, now first we have to find the velocity of two ball system. From that velocity we can find out the amplitude of the system. Okay, now velocity of the two ball system can be found out by finding the center of mass of velocity of the ball system. Now the system velocity will be equal to the center of mass velocity of the system. Now the velocity of the center of mass of the two body system can be find out by the velocity center of mass formula, that is velocity of center of mass is equal to the m1v2 plus m2v1 divided by m1 plus m2, that is equal to the, by applying the conditions here, v1 is 0. Okay, then it's become m1 into v2 where because m1 m2 m3 is equal to the m, so it's become m1 into v2 divided by m plus m. It gives us m into v2 divided by 2 times m will be cancelled out. Of mass will become equal to the velocity of 2 divided by 2. Velocity of body 2 is 1.2 meter per second. By dividing it by 2 it gives us 0.6 meter per second. So this is the velocity of the center of mass of the two identical bodies having connected by a spring. Now we have to find the relative velocity of center of mass with respect to the body 2. So the relative velocity will become equal to the v2 minus velocity of center of mass. v2 is 1.2 meter per second minus 0.6 meter per second. It gives us the relative velocity here is 0.6 meter per second. Now for any system we know that the total energy is equal to the kinetic energy relative. Okay, the total energy is equal to the 1 by 2 mv relative square. Now the total energy for a mass attached to the spring system is equal to the 1 by 2 k times the amplitude square. So 1 by 2 k times the amplitude square is equal to the relative kinetic energy, that is 1 by 2 m into v relative square. The 1 by 2 cancel out. So the x maximum square is equal to the m by k into v relative square. By taking under root it gives us x maximum is equal to the m by k under root into v relative. Now by placing the values of m and k and v relative velocity, m is 0.15 kg, k is 0.875 and velocity is 0.6. The relative velocity here is 0.6 meter per second. Okay. By calculating this one, it gives us x max is equal to 0.2484. By rounding the digit, it is approximately equal to the 0.25 meter. So from the option, it is x maximum is equal to the 0.25 meter. This was your final answer. Thank you for watching. Allah Peace.